The first hypothesis, the need reduction hypothesis proposed by Clark-Hull, is that stimuli will function as reinforcers when they reduce biological needs. Let's review a couple of supporting examples and some counterexamples. There's lots of evidence in lots of operant conditioning experiments that animals will engage in operant responses in order to obtain access to food and water. This is especially true if the organism's access to food or water has been limited in the period of time leading up to the experimental session. So for example, if you have a rat pressing a lever in order to obtain access to food, food is going to function as a more effective reinforcer if that experimental session happens before the animal's daily meal than if it happens after the rat's daily meal. So food and water are evidence supporting the need reduction hypothesis. Artificial sweeteners, on the other hand, are counterexamples. Artificial sweeteners have no caloric value. They serve no particular biological need. They contain no nutrients, and yet humans and other organisms will prefer food that is sweetened with artificial sweeteners. And artificial sweeteners will function, in other words, artificial sweeteners will function as a reinforcer, even though they definitely do not serve a biological need. You might think of sex as fulfilling a biological need, but sex is not necessary for the maintenance of health or for survival, right? No organism will die for lack of sex or even suffer any, there's no evidence that there's any deleterious effects of abstinence. It's not necessary for our survival or for the maintenance of good health. On the other hand, thiamine, vitamin B1, is something that mammals have a biological need for. It is necessary for the continued maintenance of effective brain function. And yet, the rats and humans can't detect it, and which means that we don't prefer food that contains thiamine over food that does not contain thiamine. So we have a biological need for vitamin B1, but it does not function as a reinforcer. So finally, warmth is another stimulus that functions as a reinforcer and arguably does reduce a biological need. So if you put a rat in a cold operant chamber, then it will press a lever in order to obtain access to warmth in the form of turning on a heat lamp. So we've identified 3 supporting examples, food, water, and warmth, and 3 counterexamples. So one strength of the need reduction hypothesis is that it makes some intuitive sense. Biological necessities should function as reinforcers because we wouldn't survive if we weren't strongly motivated to obtain them. The need reduction hypothesis makes some correct predictions too, but a major weakness of it is that it makes lots of incorrect predictions, both about stimuli that should be reinforcers because they reduce a biological need but aren't reinforcers, like thiamine, and about stimuli that shouldn't be reinforcers because they don't reduce a biological need, like artificial sweeteners, but that function as reinforcers anyway. As a follow-up to the need reduction hypothesis, Neil Miller proposed a drive reduction hypothesis. According to the drive reduction hypothesis, reductions in stimulus intensity are what reinforce behavior. So the thinking is that strong stimuli are necessarily aversive, and so reducing the strength of the stimulus functions as a reinforcer. In this conceptualization, food and water continue to be supporting examples because they reduce the aversive intensity of hunger and thirst. Sex becomes a supporting example, although it's not necessary for survival. You can think of a sex drive as building up and then getting relieved. To imagine a loud noise or a bright light where reducing the intensity of the stimulus would function as a reinforcer. So this theory has some advantages over need reduction with regard to some of its predictions, but it also has some weaknesses, at least according to Mazur. So it's not always clear what constitutes a reduction in stimulus intensity. So for example, we just talked about warmth as meeting a biological need and therefore functioning as a reinforcer, but that's only true if the operant conditioning chamber or if the environment is already cold, right? Sometimes heating will function as a reinforcer, but sometimes if you're in a hot room, cooling would function as a reinforcer. It's also the case that individuals in many species and at all stages of development actively seek out stimulation or increases in stimulus intensity, right? Certain forms of play could be considered an increase in stimulation or stimulus intensity. Thrill seeking is certainly an intense experience, even forms of sports. So Mazur's conclusion on the basis of those objections is that there seems to be no way to reconcile these facts about the non-linear nature of warmth and whether warmth functions as a reinforcer and about the sensation seeking involved in play and other activities. There's no way to reconcile those with the drive reduction hypothesis. My thinking about that is that we can view these facts as compatible with drive reduction because presumably they all provide some kind of relief of a need, right, or of a drive, social connection, intellectual engagement, something like that. Or they help to maintain some kind of homeostatic equilibrium, as with the heating and cooling. However, if we reconcile those facts with drive reduction in that way, the drive reduction hypothesis reduces to that circularity, right? If a stimulus is presented as a consequence and it strengthens the response, it's a reinforcer because it reduces some kind of drive. Now, whether this is wrong or not becomes irrelevant because, put that way, the drive reduction hypothesis is useless at predicting what will be a reinforcer. So it doesn't do what we are trying to get our theories to do. Meehl proposed trans-situationality. This is the idea that a stimulus that acts as a reinforcer in one situation will be a reinforcer in other situations. So here's an example. Let's suppose a mother notices that her teenage child will be willing to do his homework in order to have pizza for dinner. The prediction of trans-situationality is that this teenager would also be willing to do the dishes in order to have pizza for dinner, clean his room for dinner, mow the lawn for dinner, come home on time for dinner, get good grades for dinner, do a variety of things. So if pizza functions as a reinforcer in one situation, trans-situationality predicts that it will function as a reinforcer in other situations, or maybe even in all situations. So there are some strengths to this idea. It's not hard to collect supporting evidence for trans-situationality. Another strength of this idea is that if it's true, you don't need a theory or set of principles to break the circularity of the definition of a reinforcer as a stimulus that strengthens as behavior, because you can determine it empirically. However, the weakness of trans-situationality is that it's not true.